Hi, okay, so this is the video that goes with the pineapples and bananas problem of the week. I did a write-up with it where I think that me explaining it would actually work better than what my words were able to accomplish, because I had a sequence of different aha moments and there's like different mindsets throughout the whole paper. So we are given 4 different statements. 30% of students do not like bananas, 36 students do not like bananas, or 30% of students do not like pineapples, 36 students do not like bananas, 60 students like both fruits, and 48 students like one fruit but not the other. So given that information, my first assumption was I thought, oh, this is easy. All I need to do, if 30% of students do not, and it's asking how many students do not like pineapples and do not like bananas. So at first I thought it was 2 independent things, like how many students don't like pineapples and then how many students don't like bananas, and then add those together. So we know 30% of students don't like pineapples and 36 do not like bananas. So I just need to add 36 and then find 30% of my total. So I thought that my total was 36 plus 60 plus 48. So that's what the writing in green kind of walks through, is the that first thought. Well, that's wrong, because so that's what I walked through first, was I added 36 plus 60 plus 48 to get 144 students. So I was under the assertion that there were 144 students in total, to which 36 did not like bananas, and then I found 30% of 144 and I got 43.2. So I rounded up to 44 and I said, okay, 44 students don't like pineapples and then 36 do not like bananas. You add those 2 together and I get 80. So that was my first thought. But then I was realizing that 43.2, I don't think that would be in the answer. You can't really have 0.2 of a person. Yes, you can round up, but I think that I needed more exact numbers. So then I was thinking that was wrong. Well, then after talking to Dr. Duhan, I realized that I cannot be under the assertion that there's 144 students. Just because it says 36 students don't like bananas, 60 students like both fruits, and 48 students like one, not the other. Of those 48 students who like one fruit and not the other, could be the 36 that don't like bananas, so they could be inclusive of one another. So after I realized that, well, with the first one, I just thought I could eliminate, if I know that 60 students like both fruits, that's automatically eliminating 60 students from the ones who do not like pineapples and bananas. So from there I got 84, and then I thought, okay, of those 84, 48 students like one fruit but not the other, so I can subtract 84 from, or 48 from 84, and then I got 36, which would give me the 36 that do not like bananas, except that doesn't make sense because of the 48 that like one fruit and not the other could be included of the 36. So that was my first strategy, my first way of approaching it, and I'm pretty sure that was wrong. So that's where the change of writing comes in. And then the second way was to look at it from a different angle, not from the total. And then in this part, I also found that the question is not asking me how many students don't like pineapples here and then don't like bananas here. It's asking, like, for every individual one student, how many one students do not like both together. So I was also able to contextualize that that's an and problem, and in class it's the and problems that are multiplication and then the or problems that are addition. So this one would be, I would have to multiply the proportion of students who don't like bananas by the proportion of students who do not like pineapples. So I already knew the proportion for pineapples is 30%, except I don't know the total number of students. So that's where I kept kind of hitting a roadblock. And to be quite honest, I'm still at a roadblock. I don't have a definite answer solution. And so let me just walk through my second kind of thought process and then assert what my final answer is. So like I said, I cannot assume that the 36 students who do not like bananas also fall under the 48 who do not like, who like one but not the other. But if I were to do that, if I were to subtract the 36 and the 48, either way, the 36 who do not like bananas, and then the 60 or the 48 who like one fruit, not the other, that kind of means nothing, because what I'm trying to find is how many singular students do not, or I'm not, sorry, scratch that, not the 36, I'm talking about the 60 and the 48. So what I asserted in the end was we have these four statements: 30% of students don't like pineapples, 36 students do not like bananas. Those are significant for the total. But what's not significant for the total is the 60 students that like both and the 48 students that like one and not the other. So because I am wanting to know how many singular students do not like both. So what I'm able to gather from that is that there are at least 108 students. That's what I know, given no matter what, point blank period, because there are 60 students that like both and there are 48 students who like one and not the other. And that's all that those two statements basically tell me, because those two statements have nothing to do with the calculations and how many students don't like pineapples and bananas. I mean, arguably, that's like from my view. So what I was able to assert in the end is that there are at least 108 students. So from that, my final conclusion is what you need to do is multiply 30%, 0.3, by 36 over the total number of students. So if I wanted to do that, I guess what I could do is act under the assertion that there are 108 students, which I will now, like, in thinking that that's what we'll show right here at the bottom of this page. But that is my final kind of approach to take this, is because that's all that I know is that there are at least 108 students, but that's also not right, because that tells me nothing about those. So I'm still kind of stuck, but I hope that this video walked through my process and my strategy in trying to tackle this problem.